Coefficient alpha, which is sometimes referred to as Cronbachs alpha, is one of the most popular reliability measures of total raw responses to either a test or an inventory or a survey. And the alpha statistic answers the substantive question, how repeatable are these values? So if we take a look at our data frame, we see that we have three items, item 1, item 2, and item 3. And in previous videos, when we pre-processed the data, we specified these as ordered factor vectors with labels. In other words, they're specified as categorical variables with labels. So in this video, let's say we want to calculate Cronbachs alpha for our 3 survey items. The most important thing that we need to do in order to calculate Cronbachs alpha is to change the variables from ordered factor vectors to numeric vectors. In this case, we have 4 levels for each variable: strongly disagree, disagree, agree, strongly agree. And we're going to change that to a numeric variable with 4 numeric categories: 1, 2, 3, and 4, where 1 equals strongly disagree, 2 equals disagree, 3 equals agree, and 4 equals strongly agree. And in order to calculate Cronbachs alpha, we're going to use the psychometric package. So I have it installed on my computer. I'm going to load it using the library function. Now remember, in order to pre-process the variables, we have to change them to numeric. And in order to do that, we're going to use the asNumeric function. And let's store each of the 3 items in 3 separate objects. So the first object we'll call item 1 numeric. We'll use the asNumeric function. And then we'll pass in our item 1 variable. And let's do this again for item 2 and item 3. Now, if we check the class of each of these, we see that they're numeric variables. Now, the next thing we want to do is we want to take our numeric variables and store them into a new data frame. Let's call the data frame items numeric. We'll use the data frame function, and then we'll pass in each of the new vectors. Now that we have our data frame, we can use the alpha function from the psychometric package. So we see here that we have a Cronbachs alpha of 0.86, which is considered a good value, particularly for surveys. Now in the research literature, people generally only report one reliability measure for the entire survey or the entire test. And I don't particularly agree with this. Reporting only a single estimate can be quite misleading. So what I'd like to encourage you to also calculate is the standard error of the estimate, as well as the 95% confidence intervals for the estimate. So just to remember what we're working with, let's take a look at our new data frame. And we see here that we have our 3 variables and they're all numeric. So the first thing that we're going to want to do is we want to sum across each of the variables so we can get a composite score for each of the respondents. So in other words, we want to add 3 plus 3 plus 4 into a new variable that's going to be a summed composite score of this person. And we want to do that for each of the observations within our data frame. And then what we want to do is calculate the mean of that composite score. So we can do that all in one function, and the function that we're going to use is called row means. Let's first store it in a new object. Let's call the object person mean. We'll use the row.means function, and then we'll pass in our data frame with each of the 3 variables. And now if we take a look at the new object, you'll see that we have the overall averages for each of the respondents based upon their 3 items. The next thing we need to do is calculate the standard deviation for the person mean vector that we just created. In other words, what's the standard deviation of the aggregate mean scores for each of the respondents in our survey? Let's store this in a new object. We'll call it person standard deviation. We'll use the standard deviation function, and then we'll pass in our person mean object. So now if we take a look at the new person standard deviation object, we've calculated the overall standard deviation rounded as 0.67. Now the first thing we want to do is calculate the standard error of the estimate. So anytime we calculate an estimated number, such as Cronbachs alpha, it's important to also report the standard error of the estimate as well as the 95% confidence intervals. Again, because it's an estimate. So in order to calculate the standard error of the reliability estimate, we're going to use the se.meas function. We're first going to pass in our standard deviation. And then we're going to pass in our alpha statistic, which you remember we calculated up here using the alpha function. We could have stored that in an object, but here we didn't. And you'll see that we have a standard error of the estimate rounded of 0.25. Now, the last thing that we want to calculate are the 95% confidence intervals for the estimate. In order to calculate that, we're going to use a package called Cocron. I have it installed on my computer. I'm going to use the library function, COCRON. Now, in order to calculate the confidence intervals, there's 3 pieces of data that we need. First, we need our alpha statistic. So here we have our alpha. Again, that's 0.86. We need the number of rows within the data frame. So in other words, how many people have responded to our survey. We can use the nRow function to do that. And then we'll use our numeric item data frame that we created. So we have a total of 150 observations. And then the last statistic that we need is how many items were in the survey. Or if this is a test, how many test items were there. And we can calculate that by using the ncall function. And then we'll pass in our data frame once again. And you see that we have 3 survey items, item 1, item 2, and item 3. And now in order to calculate the confidence intervals, we're going to use the cronbach.alpha.ci function from the cocron package. First, we're going to pass in our alpha value. So we'll take this function right here. Next, we're going to pass in the number of respondents. So that's our nRow function. And then third, we're going to pass in the number of items in the survey. And that's our ncall function. We'll run the function. And then we see here that we have a 95 confidence interval. Our lower bound is 0.82 and our upper bound, rounded, is 0.90. So what this is essentially saying is that 95% of the time, if we were to collect new data and rerun the test, Cronbachs alpha could range between 0.82 and 0.90. Again, for a survey, that's a good number to have, suggesting that the data are reliable.